Let's solve this question here. You can take a moment and read the question first. Okay, so there are two packages here sliding down the ramp. I'm going to find how long it takes package A to reach the bottom here. First of all, what information do we have? Well, the mass of package A, the coefficient of friction of package A, also for package B. Okay, so let's write that down. The mass of package A is 5 kg. The mass of package B is 10 kg. Now, for coefficient of friction, right? Is this static coefficient of friction or kinetic coefficient of friction? Since the packages are moving down, right? So that should be kinetic. So I would denote that as mu k, right? For kinetic. And that's for package A, 0.2. And mu k for package B, 0.15. Of course, we know that the gravity is approximately equal to 9.8 meters per second square. Okay, what else do we know? I think that's it for now. We know that this distance here is 2 meters, right? And the angle here is 20 degrees. That's it. Okay, now, what does it mean when these two packages are sliding down together like this? Notice that package B has a smaller coefficient of friction than package A. That means package B is accelerating down the ramp faster than package A. And that means package B is applying a force on package A. But at the same time, package A is also applying a force back onto package B, because that is action-reaction, right? Okay, now let's draw a diagram on both packages and see what the forces are acting on them. We start with package A. Here. Okay, of course, right? Right away we have a force of gravity, right? So we call Fg. But we have to break it down into component. So would be like that. This one we call that F sub gy, and this one will be F sub gx, right? Into component. And of course, right? There's a normal force acting on the package because it's on the ram, right? So we call that F sub n. And friction is always acting in the opposite direction of where the object is going, right? So it should be this way. So we call that F sub x. Okay, here. What are the forces acting this way here? Of course, there is the F sub gx, right? Which is the gravity pulling this way. But at the same time, there's also a force exerted by package B onto A here, right? So we have two forces acting this way. Let's call this one here, right? For example, here, 1 and 2, right? So let's call this one force of B on A, right? And this one here is F sub gx. Okay, like that, right? Two of them. Now, package B. Of course, there's a force of gravity, right? Acting this way, downward. So we call that F sub g. Again, break it down into component. And that is F sub g y and F sub g x. Again, there's normal force acting on it because it's on the ram, right? So we call that F sub n. Also, there's a friction acting this way as well, right? So we call that F sub s. However, package A is in this position, right? Related to package B here. So that means when the force of A acting on package B, it will be going this way. Okay, so let me draw it like this. That's F sub s, and this would be force of A on B. Okay, so this way, right? Of course, there's gravity pulling downward, right? Down this way, right? Which is the F sub g x. Okay. Now, as you can see, these are the forces acting on both package A and B. Here. Okay, now we have to find the equations for F sub g x and F sub g y, right? After breaking it down into component. So how do we do that? Now we do know that over here, this is 20 degrees, right? From the question here, right? 20 degrees. Okay. What's this angle here? Let's call this angle theta, right? That means this is also angle theta. This is 20 degrees as well, right? Okay, so what's angle theta? Now we know that this is 90 degrees, right? So this is a right triangle. So what's this angle here? 180 degrees minus 90 minus 20 is 70 degrees here, right? Okay, so this is 70 degrees, right? Then what's theta? We know that this F sub gy force, right, is perpendicular to the surface of the ram. So this is 90-degree angle here. Since this is 70 degrees, this whole angle is 90 degrees. What's theta? Theta would be 20 degrees, right? Okay, so theta is 20 degrees, which is the same as this angle here. Same thing here, 20 degrees, 20 degrees. Then, can you find the equation for F sub g x and F sub g y? Of course, using the trigonometry, right? Okay, so here, F sub g x, right? Since this is a right triangle, right? And theta is here. F sub g x is F sub g, right? Fg sine theta. F sub g x is equal to Fg sine theta. How about F sub gy? Right? This one, right? And theta is here. So it would be F sub g cosine theta. Cosine theta. Okay. But what's the equation for Fg? It's mass times gravity, right? So that's the same as mg sine theta. This one will be mg cosine theta. And of course, right, for package A will be mass A, right? For package B will be mass B, right? So that's how it is. What else do we know? Here, normal force. Now the normal force will cancel out with the F sub gy, right? So we can say that the normal force is the same as F sub gy, right? And that's the same as mg cosine theta. What's the equation for force of friction? Now, the friction force is the coefficient of friction times the normal force, right? And that is mu mg cosine theta, right? And of course, right, if it's for package A, that will be a subscript A here, right? If it's for package B, that will be a subscript B here. Okay, so these are all the formulas. Now, we can write the equation of all the forces acting on the object now. But first of all, what do we actually need to care? We just have to care about the forces acting in the horizontal direction here, right? On both objects, both packages. Because they're going down like that, right? Like this way, right? Okay, so since we know that these two packages are obviously sliding down this way, right? This way. So let's pick this direction as the positive direction, okay? Now, one more thing. Acceleration. What's acceleration of A and acceleration of B? Now, notice that A and B are action-reaction pairs. B is pushing A downward. So that means these two blocks are going down together, are sliding down the ramp together, right? So the acceleration of both blocks should be the same. So I would just say that acceleration A is equal to acceleration B is equal to just acceleration, okay? Now, let's write all the forces. Let's write an equation of all the forces acting on package A in the horizontal direction. Now, first of all, right, mass A times acceleration, right, is equal to, of course, right, the sum of these two forces minus the friction force, right? Then is the acceleration going this way, right? It's the forces acting this way. Now, I would have to say that that would be force of B on A plus force of the gravity, right? Pulling this way for A minus the friction force of A, right? So these two forces minus this force, right? Okay, now how about the forces acting on package B in the horizontal direction? Since this side, right, this side here is the positive direction, so it would be gravity force minus the friction force and the force of A acting on B, right? So, right, that's the force of B, right, going this way, is equal to, yeah, the gravity force of B minus the friction force and the force of A on B. The friction force of B and the force of A on B. Now we have two equations. What can we do with that? Now, first of all, let's look at the force of B on A and force of A on B. Because they're action-reaction pair, right? That means the magnitude of the forces acting on each other will be the same. So in this case, I can say that, right? The force of B on A is the same as the force of A on B. Okay, if that's the case, what can I do? I can just isolate one of this, right? This force, and then substitute into another equation. I have a system of equation, right? Okay. Now, let's do this. Maybe I isolate this one here. Okay, like this. If I move this force of A on B to the left side and move mass B times acceleration to the right side, I have force of A on B equals to this minus this, right? F sub G X B minus friction force of B minus mass B times acceleration. Now, since this is equal to this, so I can replace this equation into here, right? Okay, so let me do this. So from here down. Okay, so mass A acceleration is equal to, so this is equal to this. So I will have force of gravity B minus friction force of B minus mass B times acceleration, right? So this plus this minus this plus force of gravity on A minus friction force of A, right? Yes. Okay, of course, right? I need to calculate the acceleration, right? So that I can put into another formula to calculate the time. It takes package A to slide down to the bottom. So I have to isolate all the acceleration, right, to one side. So we'll add mass B times A to the left side. So I have M A plus M, right, sub B A is equal to this. Now, isolate A. Now, I would just write all these terms into the formulas that I just calculated here, right? Okay, so F sub G XB, that would be M sub B G sine theta, right? Because that's the formula, right? Yeah, sine theta. Minus the friction force of B, that will be mu K B times M sub B G cosine theta. This one here. Plus, that will be M sub A G sine theta. Minus, the friction force will be mu K sub A, right? M A G cosine theta. Like this. Okay, now divide both sides by M sub A plus M sub B to isolate A, right? So A is equal to this. Or divide by here. Okay. Now, what we need to do is just plug in all the values that we know, right? Which is given in the question to find out what the acceleration is. Now, mass of B is 10, right? Gravity is 9.8. Psi, 20 degrees, right? Which is theta, minus the coefficient of friction for B is 0.15. Mass is 10 times 9.8, right? Gravity, cosine 20 degrees, plus mass of A is 5, gravity 9.8, sine theta, sine 20 degrees, minus coefficient of friction for A is 0.2, mass is 5, gravity is 9.8, cosine 20 degrees. And of course, all this divide by the two masses, which is 5 plus 10, right? And of course, if you put that into calculator, the value for the acceleration of the two blocks would be 1.82 meters per second square, approximately. Okay, now, you know the acceleration of the two blocks. Now, how do you find the time for block A to reach the bottom? Which is being asked in the question here, right? Okay. Now, next, find the time, which is delta t, right? Which equation do we use? Now, we have distance of 2 meters, right? So, let's say displacement, right, is equal to initial velocity times time plus half acceleration times time square. Okay, so we know this value. We don't know what v initial is, right? We don't know what time is. We know a, which is what we calculated here. How do we find time? We do know what the initial velocity is. Think about that. When the two packages were put on the ramp at the beginning, right, before they slide down, the initial velocity of these two packages are 0, right? Because they were just put there and they're not moving and they just slide down after, right? So the initial velocity is 0 meters per second, right? Okay, so let's put that in. It's 2 meters, right? Which is here, the distance here. It's given here, 2 meters. Initial velocity 0 times time plus 1/2 acceleration is this, right? We calculated that 1.82 times time square. Of course, that's 0. That would be 2 equals to half times 1.82 times delta t square. Okay, here. Then delta t square is equal to 2 times 2 divided by 1.82. Now take the square root of this. Of course, we have to take the positive square root because time has to be positive, right? And that will give you approximately equal to 1.48 seconds. Or you can round this up to 1.5 seconds. Okay, so here's the answer. It takes about 1.5 seconds for package A to reach the bottom here. Hope you enjoyed this video. Don't forget to subscribe to my channel. Thank you.